right, y'all. Today, let's look at graphing inequalities. Then these are linear inequalities. So there's a little extra couple of things to do with the graphing. And I'm going to show you a couple of them. They're different formats, like the way that the equation or the inequality is set up. And I'm going to show you some things that I think will make it so that you can always get these right. There's a popular shortcut that to me is misleading, and it doesn't always work. And so I don't think that's a shortcut if it doesn't always work. For me, a shortcut's great, and I'm all about telling you shortcuts if they work and they're effective. So hit subscribe because I'm going to help you make sense of algebra and let you get on with your life. All right, so let's jump in here. So the first one is showing us that we're already in that slope-intercept form that you've seen 100 times in Algebra 1 already, I'm sure. So you've got this little format, and that remember that you always start with the end in mind. So you always start at the 2. So you're going to go up 2 and put a point. And then remember that this rise, this slope is rise over run. So it's saying go up 7 and right 4, and you have a positive slope. So I know that my line's going to look something like that. But if I go up 7 and right 4, I'm going to be off the screen. And of course, I could move my screen around, but just for practicality for you, when you're on your paper, that doesn't always work out. So I just wanted to show you that you could also go, instead of going up and right, you can go down and left and put your point, and you'll still have that positive slope. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. And so I'm going to put a point here, and then we're going to pretend that that I can draw a really straight line. And that actually passes through both points. Extend it just past both of them, and put arrows on both ends. Now I drew a line because I'm graphing. It's just kind of automatic. I'm drawing a line, but with linear, you've got to pay attention to the inequality sign. That symbol is greater than or equal to. And it's the equal to part that shows me that this should be a solid line. So I'm actually okay. If it wasn't, I'd have to go in and kind of erase and make, this a dashed line if it was just greater than. But it's not. It's greater than or equal to. So I can leave it solid. It's all good. All right. So let's see. Now I need to know where to shade, because if this is y is greater than or equal to, then there's a ton of solutions to this problem, and they're somewhere on this graph, and that line only shows some of the solutions. So I've got to figure out where the rest of them are. And the way that you do that is to simply use a test point. So test point is what I'm saying. For me, I'm almost always going to use 0, 0 for a couple of reasons. Mainly 0, 0 is going to be the easiest thing to plug in almost always to my equation. And I'll show you that in just a second. And so what I'm saying is this point right here a point that's a solution to this inequality, or is it not? And so we're going to test that. The only time I wouldn't use 0, 0 is if that point was actually on the line already. Then I would need to pick a point that's either somewhere over to the right or somewhere over to the left of it. But that doesn't happen a lot, so you don't have to worry about it too much. So I just picked a point, and I'm going to test it. And here's what I mean by test it. I'm going to write down that equation or that inequality from up here. And I'm going to plug in, because remember, a point is just an x, y coordinate. So where I have y and x, I can plug in zeros. So 0 is greater than or equal to 7/4 times 0 plus 2. Okay, so 0 is greater than or equal to, anything times 0 is 0, and 0 plus 2 is 2. Okay, so the question is that true? Is 0 greater than 2? Or equal to 2? No, of course not. So since that is not true, that's a false statement. That means this is not part of the solution. 0, 0 is not one of the solutions to this problem. That just means that I'm going to shade the other side. of the line. And so something like this is probably good enough shading for your teacher, kind of follow how they did it in class. But that's it. You have graphed your linear inequality. All right, so let me show you one more just to kind of help you see, that one was really straightforward because it was already in that slope-intercept form. This one's not, unfortunately. So the first thing we have to do is get it to that form where it's, the y equals mx plus b. And I know it's not going to be equals, but we do want that set up. We want the y to be the only thing over here, and we want everything else to be on the other side of the equation. So first thing I'm going to do is subtract x. All right, so subtract x, and I've got negative y is greater than, not equal to, greater than, let me just undo. I'm bringing down that negative y, I'm bringing down the less than, and notice that I didn't put the minus x under the 2, I put it kind of beside it, and that's because in my brain I don't want to think, oh, that's going to be negative 2x. That's a mistake that I see students make all the time, and I don't want you to make that mistake. So I have to remember that this is a 2 and a negative x, but they're not being multiplied, so they don't get stuck together. Okay. And so if I also remember that my goal is to get y equals mx plus b, that kind of form, that means I want the x first and then the b term, which is just the number part. That's all that means. So that just means I'm going to write negative x plus 2. So I'm going to keep them separate, and I'm going to put them in this order. I'm not going to put 2 minus x because then I just have to flip them around anyway. I need it in the order with the x first. Okay, so I'm almost there, but I need y equals, or y is greater than, not negative y. So I need to divide. Well, think about what that is in front. That's a negative understood 1. So I need to divide by negative 1. So I'm just going to divide every little piece of it by negative 1. Now, remember that if you divide in an inequality by negative 1, you are going to have to change that inequality to the opposite. So it's greater than, so I write as less than. Negative divided by negative is a positive x, and positive 2 divided by negative 1 is negative 2. All right, so there's my inequality. I'm good to go so far. And now I'm ready to graph it. So remember to start at the end, start with the negative 2. So I'm going to go down 2, put a point. And then I've got this slope that's here in front, then there's nothing there. So it's a slope of 1. Well, that means 1 over 1 as far as rise over run. It's always, if it's a whole number, it's always over 1. So I'm going to go up 1 and right 1 and put a point. And you could keep going, but just generally know that that's the direction. You want to extend it out past the points. Oh, mercy. Try to make yours a lot prettier than mine. And then I drew a line. Now, was that right? Let's look back and see. This was less than. It's not equal to. Notice that it's not an equal to. So, no, it's not right. I need to go in and make this a dashed line. And so now that it's dashed, that shows that the solutions are not on the line. They come right up to the line, but the line is sort of the dividing point, and it doesn't include those points that are on the line. All right, and now I want to do a test point. So I'm going to go back and do test point 0, 0 again. And so I'm going to plug into the original inequality up here. So I'm going to do x minus y is greater than 2. You always want to go back to the original one just in case you messed up somewhere right on here. So I've got 0 minus 0 is greater than 2. 0 is greater than 2. Is that true? No, 0 is not bigger than 2. So that's false. So I don't need to graph here. I need to graph on this side. I need to shade on this side. I always say graph and I mean shade. All right. I'm not going to graph or shade where the 0, 0 is because when I plugged in 0, 0, it did not give me a true statement. So 0, 0 is not a solution. That means all the points out here are solutions. Okay, so I could test a point. I could go right 3 and down 1, and I could just test that point. So I could make a test point at, 3, negative 1. Okay, so remember, we're plugging into the original. So the original inequality was x minus 1, y is greater than 2. So this is my x and my y. X is 3 minus y is negative 1. So minus negative is plus 1. And so 3 plus 1 is 4. Is 4 greater than 2? Yes, that's a true statement. True. So that means this is a solution and it should be in the shaded section. So I just wanted you to kind of see a different test point. If I had tried that one, that would have helped me to know it works over here. And if you're ever just thinking, I don't know if I plug that in right, then try a different one. Really and truly, I'd try one that has all positives if possible. Like I can see that this is a point also. This is 1, 2, 3, 4, 1. So I could have tried 4, 1, and then I wouldn't have to deal with that negative, plugging in the minus negative thing. So, and that one would work as well. It would give me a true statement and I would know that I'm on track. So I hope this helps. This can be pretty confusing. There's lots of little bits and pieces to it. So I hope it helps you. Have a great day.